Find the partial derivatives for each function. We have a two-variable function defined as 7x minus x squared y minus 7xy squared. First, let's take a partial derivative with respect to x. Beginning with your first term, the derivative of 7x is 7. The derivative of x squared is 2x, so we'll have negative 2xy. The derivative of x is 1, so we'll have negative 7 times 1 times y squared. Those results give you the first partial derivative with respect to x. Going back through this function, taking derivative with respect to y, the first term has no y, so its derivative is 0, nothing to write. The middle term, the derivative of y is 1, times negative x squared is negative x squared. Third term, the derivative of y is 2y, times negative 7x is negative 14xy. Recall that the derivative of natural log is u prime over u, meaning that whatever trails your natural logarithm will be in the denominator. The derivative of what trails your logarithm will be the numerator. Having said that, the derivative of function g with respect to x is going to be 1 over 2x cubed plus 5y. That's your denominator. And then the derivative of this with respect to x will be 6x squared. The second term has no x, so there's nothing else to write. Applying the partial derivative with respect to y, we still take the reciprocal of all of that, both terms, 2x cubed plus 5y, and then we take the derivative only with respect to y for the numerator. That's 0, because there's no y, plus 5, because that's the derivative of 5y. Our third function, z, is a function of x and y. A partial derivative of z with respect to x is going to be 2x minus 7y, because x has a derivative of 1, times negative 7y. Third term has no x, so there's nothing to write. The partial derivative with respect to y, starting with our first term, no y, that derivative is 0, nothing to write. The second term, the derivative of y is 1, times negative 7x is negative 7x. The last term, the derivative is 2y, 2y. Taking partial derivatives, this function has three variables. It's w, but it's written as a function of x, y, and z. We're going to take the first partial derivative of each variable separately. So function w, partial derivative with respect to x, beginning with your first term. That's going to be 15x to the fourth. You pull down your y and z term, or variables, because you're only focused on the x part, taking the derivative of that. In the middle, taking the derivative of your x term, that's going to be a negative 2xy. Third term, there is no x, so its derivative is 0. Taking the derivative with respect to y, the derivative of y is 1. 1 times 3x to the fifth, z to the fourth. That'll be the derivative of the first term. The middle term, derivative of y is 1 times negative x squared is negative x squared. Third term, derivative of y is 1 times negative 4z squared is negative 4z squared. Finally, going through and taking the derivative with respect to z. Z to the fourth has a derivative of 4z cubed. 4z cubed times 3x to the fifth y is 12x to the fifth y, and then we still have our z cubed on the end. The middle term has no z, so its derivative is 0, nothing to write. Third term, the derivative of z squared is 2z. 2z times negative 4y is negative 8yz. let's see. You know, guys, look, you've already paid your dues with the final, so I don't need to remind you of that.